Number 20. Consider the following graph of position versus time, which represents the motion of a certain particle in the given potential. So let me start out with total energy is equal to total mechanical energy, or delta E, is equal to delta K, kinetic energy, plus the potential energy. And as you see in this graph, position versus time, you will notice that our position is not moving at a certain time, that is at 2 seconds, 6 seconds, and 10 seconds. What that means is that we have kinetic energy equals 0. So we can plug it in k equals 0 at t equals 2, 6, and 10 seconds. And then what we notice is potential energy is basically the total energy. And let's take a look at our graph above. Potential energy on the vertical axis versus the position on the horizontal. So at 2 seconds, our position is at 5, so you go to 5 here, and you will notice that our potential energy is -5. So in other words, our total mechanical energy is -5 joule. Alright, so let's see what happens in other time. When we go to 6 seconds, okay, we have the kinetic energy equals 0, just like 2 seconds, and that means our potential energy is at maximum. So let's go to our position -5. So you go -5 here, and then you go up. It's same kinetic, the potential energy, so -5 joule again. And you will notice that at t equals 10 seconds as well, so you have again, you are back to the 5 meter. And when you look at our potential energy, the corresponding potential energy, you will see we have -5 joule. So this tells us our total energy of the particle just by looking at the plateau of this position versus time graph. Our potential energy is -5, the total energy. So the answer is A. So we can also deduce from this graph that our kinetic energy must be at maximum around 4 seconds and 6 seconds. So we will likely to have potential energy to be 0, and kinetic energy will be probably not, it should be the maximum at that point.